Here from Kirby, we are presenting a case study of an beautifully structured composite structure for gas point project in Nagpur. It is in the heart of a city wherein had a lot of complexities. You can see in this beautiful architecture elevation that it has cubes, it has a lot of cantilevers. Up to the sixth floor level is an office area, and above it is a residential area. And on the terrace, we have the swimming pool and the gymnasium and small garden area. These are about the project highlights. It's an G+13 office cum residential building. The project tonnage is approximately 2,000 metric tons and the floor area of 1.1 lakh square feet. The building height, it is below ground. It is on the basement, it is minus 10.5, and above ground it is 58 meters. So below it was used in a utility and for the parking area. Ground plus ground is an entrance lobby, and above the office floor up to the sixth floor level. Seventh floor is an refuse area, and from eighth floor, it's a duplex residential area. The composite steel structure foundation inverse consisted of the box columns, concrete infill, I-section beams, which are moment connections with the nut bolting, the column splices to take care of the floor space and all. They never wanted an structure design, did not wanted an the area to be taken into with an end plate connections. So it was to be have a flush joint, so gone with an field weld connections. And the box girders, which are for the residential area above, from the 8th floor onwards. So those were again field weld connections. This is a typical Tekla model and the building elevation to give a glimpse about it, how it is and this. So here we use this model for all the three purposes, that is for the project management, understanding how about the project is to be executed, how the segments are to be executed on the site, the transportation about the segments, and the care to be taken from the safety point of view, because if you can see in this building, in this initial site condition, that on the left-hand side, you can see that pink color, that is an volleyball school, which is sharing and compound with this plot area of only 1,400 square meters. Backside is an hospital. On the front side, you see the road is there, and other side it is a 4-lane road. This is a single-lane road about it. Anchor bolt fixing, it was a raft, and then we started with an chemical anchor bolt fixing for this one. Now here we had a big challenge because it is in a purely, what we can say, the traffic zone area. We were not getting an permission for keeping a crane on the road and doing an erection. So we came with an idea that up to the ground floor level, we'll go with and dropping a crane inside the pit area. We'll do the erection up to the ground floor level, and then we'll go with an tower crane. So the tower crane placing was also a big challenge because entire plot area is a very constrained plot area, and we had only a small notch because that is an architecture notch. We got it and we use it, and the space without going into another this thing, we can say the municipal areas and all, and in that area only we place the tower crane. And the care was taken with this that it should not hamper with any of an building elements, so because that we won't be able any chance later future to connect that one, because on this elevation only we have the pergolas, architecture pergolas, and accessing that area later stage will be a big challenge. Typical office floor plan where you can see that notch area. Now here this tower crane, when we are finalizing, we use it the entire plotting about the radius and all, and we segment we understood what are the segments, what are the weight for it, and how we can distribute it and use effectively the tower crane also and the timelines also, and with the safe erection. If you check it up from this tower crane to the farther area, which is here, it is 50 meters, And we have to take care about the boom and the load carrying capacity. 16-ton capacity crane, we used it here. The second challenge was of an architecture. It was having an elevation wherein the floating roof was, floating floors were there, which were connected with a floating column, which was starting from the second floor level, and it will be terminating with an 8th floor level soffit. This 88 square meters each floor, and it is going to carry a total load of altogether 92 tons. So here we came with a trussel, temporary trussel we designed. We kept it on the ground floor slab when it is. For that ground floor, we have to do from the bottom the strengthening about it. And the hydraulic jacks were used for this one. So the entire system, if you check it up, we had to go with all the team players from the Kirby, the engineering team, the sales team, the project management team, the procurement team, and the construction group to understand, and our safety team to understand how it is to be done about it. A lot of brainstorming has gone because of the safety parameters, the speed of the project, the technical part involved into this. Now here that challenge we can see that the columns are having a flush joint which we have to go with an welding. The heat stresses to be controlled and all, we gone with a MIG welding, which can deploying about 15 certified welders. Every column connection, every beam connection on the site what we are doing, we did 100% of an UT testing to get it more satisfactory and proceeding with and without any technical challenges in future. Cantilevers, the building when it came above the ground floor level, it was getting on all the sides the cantilevers with 2.5 meters, and it was proceeding further. Now assembling that members on the ground, we don't have any space for it, so we had pre-assembled it on the other side. We traveled it with the help of a trailer, which was like we got a space 5 kilometers away from the building area. There we have to assemble it and connect it and bring it here on the trailer itself with the help of a tower crane. We used to lift and place it up. This is a typical 8th floor level from where we started with a residential area. Now here, when you check it up, this is a residential floor plan. Why I'm showing about this photograph is that when we are coming from the ground level, we have come with an one column center, and here the column is getting away. To take it up, the floor space as per the accommodating the room sizes, and to carry and effectively check it up about getting a room feel about the residential area, because office floor is a different and the residential part is a different. So this was a critical part from right from erection part of it, how the cranes are going to be sealed and considering the CG and the field welding about it, fabrication in the plant, because the box is of, if you check it up, this box are 1.5 meter depth, and on the top it is the flanges of 900 mm, the top width about it. You can see here the small segments also on the left-hand side picture, the small segments. These were all taken into consideration inside the plates and all, load carrying capacity of the crane and the boom. Because we cannot go with that, the same typical way, entire member fabrication of the sections and all. So we had chopped it up, where it is coming the load, where we can lift it up as per the boom length, we are taken about it. Here you can see the cantilever where we had an 125 mm positive camber to take it care about this one. Another part I wanted to say about it when we were talking about the tower crane placement and the boom cover, because the adjacent building, what you can see, it is on diagonally part, it is within a radius of 20 meters. And then we had a challenge about the headroom clearance for this one also. At the terrace floor level, we have a swimming pool, again a structural steel members. Beautifully, we taken care about it, how to make it, how the segments to be connected and the field welded, because it had again a soffit down for a sunken slab area for your decks, our deck sheeting and the concreting over the same. Again the walls, wall framing, and we provide with the deck panels there also, and which will done with a parapet like and walls in total RCC, and inside they're given the treatment for an swimming pool. This is an under execution photograph, aerial photograph. We can have a look. The beauty of it is that when we were going above, from the 8th floor onwards, we had already handed over the bottom floors for starting with the civil activities and without losing a time about it. So the block work for even the interiors were started for the office area. So when we came up to the terrace area, the 2 floors were also ready to take it up about the wooden woodworks and the flooring and all. This is what we had initially shown the photograph of an architecture thought process, the beautifully, what he has thought about it and design, and what we are getting. The cantilevers, the facade has happened and all. After the structure was removed, the temporary support panels, when the entire structure was erected and finished and all, when we removed the structure from the bottom level, we achieved the positive camber without any deflection. We got a verticality, entire structure is in the verticality of 6 mm tolerance. This is about the office area being occupied and being used. And as an engineer, we get it proud that, okay, all the people have, and then we get a client appreciation for giving a beautifully structure, composite steel structure with a tolerance and within a timeline and all. That is it. Thank you.